Our immune system is like our own personal army, right? It's fighting off invaders 24/7. But what happens when that army gets confused and starts attacking its own side? Well, that's what we're diving into today. The incredible world of immunosuppressant drugs, the agents designed to bring peace back to a body at war with itself. We're going to explore what we're calling the body's civil war. Then we'll look at how we actually tame the immune system. After that, we'll get into the really tricky part, a delicate balancing act. And finally, we'll take a peek at the future of treatment. Sound good? Let's go. So, first things first, we have to understand what we're up against. What exactly happens when our own protectors turn into aggressors? I mean, it's a pretty scary question, isn't it? The very system that's supposed to keep you safe suddenly misidentifies your own healthy cells as the enemy. And when it does that, it launches a full-on attack. This friendly fire is what leads to a whole range of conditions we call autoimmune diseases. And just look at how different these attacks can be. With rheumatoid arthritis, the immune system zeroes in on the joints. In lupus, it can be a widespread assault, hitting everything from your skin to your kidneys. With MS, the nervous system is the target. And for type 1 diabetes, it's incredibly specific. It destroys only the cells in the pancreas that make insulin. So it's the same core problem, a case of mistaken identity. But the battlefield can be anywhere in the body. So why does this even happen? Well, it's rarely just one thing. The research points to this really complex cocktail of factors. First, you might have a genetic predisposition, certain genes that just make you more vulnerable. Then, an environmental trigger, maybe an infection or a toxin, acts like the spark that lights the fuse. And finally, the system's own safety switches fail. Scientists call this immunological dysregulation, but you can just think of it as the internal controls going offline. Okay, so if the immune system has gone rogue, how in the world do we stop it? Well, that brings us right to our next section, the amazing drugs that can actually tame it. And here they are, immunosuppressants. The name says it all, really. They are drugs specifically designed to turn down the volume on the immune system's activity. Their entire job is to tell that overactive internal army to stand down, either by suppressing it completely or just modulating it to be less, aggressive. And it is really hard to overstate how critical these are in modern medicine. We've talked about treating autoimmune diseases, but they're also absolutely essential for organ transplants. Without them, the body's immune system would see a new kidney or heart as a foreign invader and destroy it. They're also key for managing other serious inflammatory conditions where the immune response itself is the problem. Now, this isn't a one-size-fits-all kind of deal. Doctors have a whole toolkit to work with. You've got the classic calcineurin inhibitors like cyclosporin, which were a total game changer. They work by blocking T cells, the foot soldiers of the immune response. But now we have much more targeted options. Monoclonal antibodies act like guided missiles, hitting very specific immune cells or messenger proteins. And then you have JAK inhibitors, which are really clever. They work inside the immune cells to shut down the signaling pathways that tell them to attack in the first place. All this variety means treatments can be much more personalized. But, and this is a big but, turning down the body's main defense system is, as you can probably guess, a really serious business. And that brings us to the central challenge of this whole field of medicine. This quote from the paper just nails it. It's all about walking this incredibly fine line. You have to suppress the immune system just enough to stop it from causing damage, but not so much that you leave the body totally defenseless against actual threats. It is a constant negotiation between benefit and risk. And this slide lays out that trade-off perfectly. On one hand, these drugs are lifesavers. They ease symptoms, they slow down diseases, they save organs, and they give people their quality of life back. But the other side of that coin is real. A weaker immune system means you're more likely to get infections. The source also points to other serious risks like a higher potential for some cancers, metabolic problems, and even damage to vital organs. It's a profound choice. But you know what? That high-stakes balancing act is exactly what's pushing science forward. So let's look to the future, which is all about developing smarter and much safer therapies. So what's the ultimate goal? It's simple to say, but incredibly hard to do. Researchers want to move away from, let's say, carpet bombing the entire immune system. They want to get much more specific, like a surgical strike. By enhancing specificity, they can take out only the rogue parts of the immune system while leaving the rest of it strong enough to do its job. And all of this is leading us toward the holy grail, truly personalized medicine. The whole idea is to stop treating a disease and start treating an individual. This means using genetic tests to see how you might respond to a drug, finding biomarkers, which are like biological signposts that predict success, and then using all that information to create a treatment plan that is tailor-made just for you.
And the innovation is just incredible right now. We're seeing more and more of those super specific biologics. Scientists are creating new drug delivery systems. Think of it like a smart GPS that takes the medicine exactly where it needs to go and nowhere else. And they're constantly discovering new targets inside our immune cells, finding even better switches to flip to restore that all-important balance.
So, what's the big takeaway here? Well, immunosuppressant drugs have totally revolutionized medicine. They are a cornerstone of treatment for millions of people, and they are constantly, and I mean constantly, evolving. The whole field is driven by this one goal: make these incredibly powerful therapies safer and more effective for every single patient.